Hey, it's W5HRO. I have some updates here. Let me show you what I got so far. See, I get, that's 400 watts carrier. And if I turn the audio up and modulate, yay, yay. And that was going past, you know, a couple thousand, but that's going to be limited. So what I'm going to do is that you probably remember in a lot of my earlier videos on this transmitter, this is what, like part 55 or 50. It's like people probably look at that. How many videos has he done on this transmitter? This has been like several years in the making. So anyway, I'm going to have that AVC control so I can limit the top peaks on it by controlling the signal to the 810s. It's going to like keep it from going up to higher than a certain point, and that'll be the end of it. Blink, you probably wondered what just happened. Hey, I'm splicing videos. But anyway, I think I pretty much determined what had happened, why I didn't realize the tube I was using in this thing for the past 2 years had gone bad on me, or was halfway bad, at least when, you know, it first started. If you remember when I first, we moved to this location here in this new home, which is supposed to be our final home, but we could move one more time, but I don't want to digress. First thing I did was, if you remember, is I converted this from 220 to 110, the supplies, right? The primaries on the input on the transformers. And I wound up finding out, remember, the solid state relays were bad, and I wound up finding some really heavy mechanical ones, and I put those in, and that's what's in there now. So remember, I had to retrofit that, and remember, it took me a while to figure out what was going on. I couldn't figure out why thing wouldn't key. When I hit I hit the mic, it wouldn't, because I was just testing to see if I could key the thing, right? And it wouldn't, I couldn't get the voltage to the primaries, and I come to find out, remember, those solid state relays were bad. But here I am digressing. So when I did that, remember, I got that done. The next thing I did was I spent that first summer we lived here out in the garage building this T368 exciter. And when I got that working, remember, the next thing I did was I decided to wire up that the 3 diode negative peak limiter in my modified design, but I didn't have a supply for it yet. I hadn't built one for it or hooked one up anywhere. So remember, I had that old screen supply when I redid this RF deck. I used that old screen supply that I used to use to power up the screen on this tube. I used that to build the supply. Then I had the solid state relay in there too, but that was after the. Remember, I had that heat sink with those two transistors to try to make like a current amplifier, and I had some series Zeners in series to regulate the voltage like to a certain voltage. I think it was like 280 or 275 or something like that. That's where I was. That's where I started out, but I wound up going higher in the end. But that's what I did. And if you remember, I got on the air and I used it for a week. And then what happened is I remember that following Saturday, I was in the morning, I think I was talking on 40 meters earlier or something, and I was on 75 and I got on 40. And then later that late morning or early afternoon, I remember I came in here and I started, what's that burning smell? Well, it was that old screen transformer I'd built that Keep Alive supply with for the limiter. You know, I found that the relay was shorted and those transistors were shorted. So what happened when those things shorted, something happened to kill that transformer. I don't know what. It was just the thing was loading. I guess when it shorted, it started drawing really high current. But what it probably did remember the thing that I just did by adding that relay in there? I took that old solid state relay out that was shorted and I put that mechanical one in there so when I'm not transmitting, the voltage from that Keep Alive supply is not on the limiter. It's not there, so it's not going up through the diodes and resistors, throwing a little bit of current on this plate and the screen. So that's what I think happened when that supply shorted. It probably threw it on the tube, and I never knew it. It probably happened when I was upstairs, and that came down. That supply was just slowly burning up because it probably just shorted it out completely in the end. But the voltage more likely was going up to everything, like what my last here modification stopped from happening. So, but you got to remember, the next thing I did is I rebuilt that supply to what I have in there now, and that supply I have in there now, there's no way that'll ever go bad. So anyway, never say never, but I'm pretty confident. I know when I overbuild stuff, I know there's nothing going to go wrong with it, and that's why I like to overbuild a lot of the time, just so I never have to worry about something going bad. But anyway, when I rebuilt a new supply and tried it out at the same time, remember I had just got this meter for the Ameritron and was using it. I said I want one for this transmitter, so I ordered another one, right? I had changed meters, and remember one of the first things I said was, why is my power down? Why is it, I'm seeing like just under 300 watts, and it was like 400 some watts before. Why is my power down? I couldn't figure out what was happening. So, remember the first thing I did is I swapped it out for this other meter, and it was within plus or 5 minus watts. It was the same, right? So then remember I had that little MFJ tuner mounted on this shelf it's that 300 watt tuner, had that meter on it. So I stuck it in bypass mode, I hooked it up, and this was all on dummy load. And I was seeing the same thing, about just under 300 watts plus or minus, 5 watts or so. So yeah, so I thought, okay, that Radio Shack meter, here this whole time I thought I had 400 some watts, and I didn't. So I didn't think any more of it because I had 3 meters all reading the same thing. And it's just the timing of when it happened, I think. So as time went on, when I tried to use a transmitter this winter, I noticed I'm only getting like 250 watts now. So I left it on all night, a couple nights, and that's when I started noticing when I came in the morning, it was like 175. Because that new supply, because that solid state relay in there was shorted, I thought, it'd be okay since I got a grid link resistor to ground and the voltages were so low. But I think the screen voltage was probably higher than it should have been, and it probably did something compared to the plate voltage. So I think that's kind of what happened, maybe not, but I think that's what happened. So anyway, but I'm like about 98% positive that's why I didn't realize that tube was bad, and I'm pretty confident at that. But I could be wrong, but that's pretty much what I think happened. So now with the new tube in here, because the other night what I did was, that old Radio Shack meter's out in the garage. I thought, let me try. I hooked it up. Sure enough, it's showing the same 400 plus watts. So all my meters were correct. It was just, I didn't know I damaged the tube when that first limiter had shorted out and melted that old little transformer I used to use for the screen that I built that Keep Alive supply with. So that's what happened. I mean, like I said, I'm 98% confident that's what went wrong. So I fixed all that and everything, and it's good now. So did I go over what I said about this? When you load it, the proper way to load this transmitter now is, the first thing you want to do is you just turn the grid drive up a little bit, key it, and if the screen current's too high, back the load down, below 30 milliamps. Because this 4400 tube, to operate Class C phone, it's normally the screen is 12 milliamps, the screen is at 30 milliamps. So what you do is you just keep bringing the grid drive up and adjust the load until when you have 12 milliamps of grid drive here on the control grid, you've got the load set to where you have 30 mils of screen current, and you leave it alone. And when I do that, you know what I see? This is cathode current. What's funny is that my modulation transformer was designed for a secondary current of 330 mils. So I thought, let me just kind of start with that, because I wanted to make sure I wasn't going to hurt I wanted to make sure it wasn't too high. I wasn't worried about the tube. I can replace the tube. It's the modulation transformer, that one I had Peter custom line for me all those years ago. I can't get another one of those. So anyway, so I was being careful with that. But so, and I realized, okay, so I started with 330 milliamps. And I thought, okay, I'm seeing 370 mils. It's just a little, it's the two tick marks past 350. So I thought, okay, 330 mils, and I have 30 mils of screen current, 12 mils of grid current. That's what, 372 mils? Voila, that's what I'm seeing. The only funny thing is, a 4400A is only supposed to draw about 275 mils in this configuration. So where's the extra current coming from? That's what I'm, it's not really an issue because I've been using it and I tried it and I had the thing keyed down the first night I tried it with everything turned down, of course. I'm keeping the audio down to keep it. I tell you what, I was sitting there the first night I used it. I had a 2-hour-long QSO with somebody and the watt meter, every voice peak, whether it just everything, it was just staying there at 1500 watts. On every syllable, and I kept it right there. If I got up in the mic, it would go over. So I had to, I turned the mic gain down just a little bit. But I'm going to solve that problem because I'm going to have that the AVC tube in there, AVC control, and I'm going to limit the peak-to-peak swing going into the 810s by limiting it from what's coming out the drivers. Or what I'm going to have is I'm going to do that circuit. If you remember, it's going to have the buffers. I'm going to eliminate the driver transformer. That's after I get the vacuum variable, I get everything on this RF deck completely done. So anyway, but I had a long QSO and it was like sitting there, and I had it to where it was just at the max peaks I was sitting 1500, but it was staying like 1400. I mean, it was just staying there the whole time. The way I had, because I had it up kind of high, so I had everything sort of compressed, that if I didn't raise the loudness of my voice, it was just staying down below it. It's pretty funny. But it works like gangbusters now. And I didn't remember, I showed you out in the garage where I had the RF deck out there. I thought, well, let me change that one Zener. I didn't do anything. I just, let me try changing the tube first, and that's all it was. So there was no sense of doing anything else I didn't want to change too many things and add a bunch of variables when I'm trying to debug something. Change tube, voila, there it was. So that solved that problem. But I kind of wonder, that that iMac, the plate, the anode on that tube was just glowing just a little bit orange. It wasn't getting too bright. The brightness was just right. It was like loafing at that, when I'm seeing 370 mils of cathode current. So where's the little bit of extra current coming from, I wonder? Could the Keep Alive supply being connected to everything be doing that somehow, maybe? Because it's coming up through and it's butting heads with the plate supply. Could that be what's causing it, maybe? I wonder if that's where the extra current could be coming from. But in any event, it's the exact current that I need on that secondary of that modulation transformer. Because I had Peter design, I just told him, I told him I calculated it myself. I said, here, just take your desk kilowatt transformer, which is the same thing as the KW1 transformer. And the original one, it's supposed to be 12K, people. It's not supposed to be 18K on the primary. 18K is wrong, man. I won't go into, I should go into it, but all I'll say is that was a dirty fix that Collins used to fix a problem, because that Pi Network audio filter, that splatter filter they put after the modulation transformer primary to the tube would damage the transformer. And there was a reason for it. That thing would try to resonate it at around 2 to 3K, right around 2 some odd KCs, and it would try to it would try to match the freaking output of the transformer to the tube, and it would create a bad mismatch every time it happened, and it kept loading the thing down. So their solution was, let's just make a transformer, and instead of admitting we have a problem, let's just send out a service bulletin. We'll just sell people a new transformer wound with an 18K, plate-to-plate primary. That was their solution, when all you had to do was unhook that stupid splatter filter to keep it from blowing the transformer. Here I went off on a tirade, didn't I? But I had to get that off my chest. That was long overdue. So it's 12K plate to plate for 810s, people. It's not 18K. That was just Colin's dirty fix to get around a problem that they didn't want to admit that they created with that stupid circuit. So anyway, there, did that get that? There, it's off my chest finally. So anyway, but that's what I had him do though, is I just said, take that desk kilowatt KW1 transformer you sell, and first, I don't want it gray. I want it painted black. Gray's ugly. I want to match my other transformers. And I told him this is the ratio I want it wound for. No low power taps, no high power taps on the primary. Just what I needed for that CG, that Pinna Laboratories tube that I had in there in the RF deck, which is designed for 330 mils. What do you think? 330 mils. So maybe it's a good thing that I have an A in there now and I'm not using a CG. So maybe that's what I'm thinking. Maybe a little, somehow it could be partly related to somehow, maybe it could be filament current somehow getting induced, maybe raising it, maybe some stray on maybe lead links on the filament transformer. I don't know. It could be a little bit higher. Maybe it could be adding some resistance. It's making it read a little high, from ground. I don't know. I'm just rattling stuff off in my head now, trying to brainstorm possibilities of what it could be. But chances are, after the more I think about it, it's probably because I have the Keep Alive supply connected, and that's probably why it's a little higher. Or it's just something like the filament current is somehow changing it a little bit. But in any event, I've got the exact current that I need on the transformer, because the 810s is exactly where I needed it to be, and it's perfect. So I've got I have a perfect match with that modulation transformer. I have the 810s perfectly matched to this tube that I have in there, because that's secondary C in 330 mils. So it's probably a good thing that I have the A in there now instead of the old, and that way I can also, and I do have, like I told you, I've got that 4400C in there, that new one, that iMac 2. That one's never been used. That's new old stock. So I've got a heftier one that's the same specs as this one. It just has carbon on the anode to make it its life and make it a more durable tube. It's just a spiral carbon graphite plates. Those are the ones that you can run at they're designed to run at the higher plate current of 330 mils instead of 275. So anyway, that's all for now. I digress, but I think I explained most everything, and it's alive and working. Now I just have to, I'm going to finish the RF deck by putting that vacuum variable in there next. There's a couple little tweaks. There's some modifications I want to make to this grid drive and stuff, and this is the switch that, if you might remember, that I actually did for when I was thinking about making this thing work. I was going to change the bias over to AB for SSB operation using that old Heathkit sideband adapter I was thinking about mounting with the T368, but I realized, as soon as I realized the coax problem trying to drive that 810, trying to drive the 4400, I went, okay, forget that. I 86 that idea right off the bat, but I'd already installed this. So my plan is to use that supply, because I have to figure out a way, because this thing will go up to like 60 mils and a little past it where it stops. So I want to put like a clamp to where no matter what I do, it won't go past like 50 mils. It'll handle 60, but I don't want it to go past like 50. And I think if that supply that I built in there for that, if I can inject that into that 1625 clamp tube, if you lose all grid drive, if I can figure out a way, maybe I can make that just partially on a little bit to where it'll just keep it from going up. So, because I'm never going to run it like that, but it's just a safety. I want to make sure it's limited to a certain point. And right now the limit's it's limiting the thing, but it's not limited enough. And I want to make that limit a little better, so it can't go up as high as it's going. So that's all for now. My God, how long have I been going on here? About 2 minutes on the first one. This is about a 20-minute video. So, but that's all I'm going to do on this transmitter for now. I finally got the thing full power out, and I'll just keep tweaking all these things over the next year or two, and It'll be gooder than snuff once I have it all done. 73s, this is W5HRO on a Friday. And I will have this thing on the air tonight. I'll just have the audio gain turned down. I'll just be careful and make sure it stays below 1500 watts. And that's all I got to do when I'm modulating. 73s.